An abstract method declaration is override a virtual method. This class A declare a virtual method. Class B override this method with an abstract method, and class C also override the abstract method to provide its own implementation. Final category of this abstraction is abstract property. An abstract property declaration does not provide an implementation of the property accesses. It declares that the class support properties but leaves accessor implementation to derived classes. In this slide, shape class contains an abstract property. So that is all about the abstraction.
Another primary concept of object-oriented programming in C# is polymorphism. Poly means many and morph means form. Polymorphism means the ability to take more than one form. Here a single function name can be used to handle different types of arguments. The behavior depends upon the types of data used in the operation. As an example, you are a person, which person is a base type, and you are a more specific representation of that type. There are many people that inherit that type, of which you are a concrete implementation of that type. You have your own attributes and qualities that go beyond just a general person. For instance, we all have a blood type, shoe size, arm length, and many other properties, but we each add our own implementation to the person interface. Polymorphism allows you to invoke methods of derived class through base class reference during runtime. It has ability for class to provide different implementations of methods that are called through the same name. Polymorphism provides at least two benefits. The first benefit is the old code can use new code. This is arguably the biggest benefit of object-oriented programming because it allows you to extend or enhance your system without modifying or breaking existing code. Secondly, it gives you the ability to group objects that have a common base class and treat them consistently. As an example, if we have three different object types like line, circle, square, we can treat them all as shape objects because they all derived from the shape base class. Polymorphism in C# can be implemented in two ways. They are method overriding and method overloading. Method overriding is a class redefines a method of another class using the same signature. Runtime polymorphism is done using inheritance and virtual functions. Method overriding is called runtime polymorphism. It is also called late binding. When overriding a method, you change the behavior of the method for derived class. In the example shows the person class. This will be the base class for other objects to inherit from. It has a single method named talk. The talk method has a virtual modifier. The virtual modifier indicates to derived classes that they can override this method. The talk method of the person class performs a single action of printing the statement hello world to the console. These classes inherit the person class. Student class has a talk method and the talk method has an override modifier. The override modifier allows a method to override the virtual method of its base class at runtime. The override will happen only if the class is referenced through a base class reference. Overriding methods must have the same signature, name, and parameters as the virtual base class method it is overriding. Compile time polymorphism is method and operators overloading. It is also called early binding. In method overloading, several methods with the same name can be defined but distinguished by their signature. They must have different type of parameters. In the code, if you observe talk method is called 2 times, talk method will work according to the number of parameters and type of parameters.
Firstly, describe what are the special things in inheritance in C#. Multiple inheritance not allowed in C#. The object class defined in the system namespace is implicit in ultimate base class of the older class in C#. Interfaces in C# can inherit more than one interface. This is a graphical representation regarding inheritance. Employee can be a person. Patient can be an employee. What is the inheritance important? Inheritance is a relationship between classes. From further analysis, we can express it is a technique derived new classes from existing classes. In this relationship, child class inherits the members and methods of a parent class. In object-oriented programming, inheritance is a strong and fundamental relationship. For example, I have a son who plays in a high school marching band. In the marching band, he fulfills many roles, but the role that is strong and fundamental is that he is my son. The fact that he is a trumpet player, a section leader, or a small peer is a secondary. In an object-oriented system, I would model the father-son relationship using inheritance. Important. In object-oriented, the concept of inheritance provides the idea of reusability. Reusability means we can add additional features to existing class without modifying it. In object-oriented programming, the concept of inheritance provides the idea of reusability. This means that we can add additional features to existing class without modifying it. This is a good advantage for programming. This is possible by deriving a new class from existing one. The new class will have the combine of both classes. Thus, the real appeal and power of inheritance mechanism is that it allows the programmer to reuse a class that is almost, but not exactly, when he wants, and to tailor the class in a such way that it does not introduce undesirable side effect into rest of the class. This is the UML class diagram. The flying bird is a bird. Non-flying bird is a bird. Parrot is a flying bird. Penguin is a non-flying bird. These things represent in this slide. Same as the previous one, this is also UML class diagram. This diagram implement employee can be a salaried employee or non-salaried employee. The base class is employee. Salaried employee and non-salaried employee are derived classes. Next thing is implement calling base class and derived class in C#. In this code, describe how to define constructor, variables and other methods. The employee class does not define any constructor, so it has a default constructor. The system first invokes the employee default constructor, then the salaries constructor. In many real applications, we will write multiple constructors for classes. As soon as we explicitly create any constructor for a class, must explicitly choose the constructor to invoke. When class has no explicit constructor, the system always invokes the default constructor. The salary constructor must specify which employee constructor to invoke.